In part 3 here we're going to look at debayering, what it is and how we do it in Pixinsight, and also how we select our images using Subframe Selector. When we take an image using our DSLR camera, we take the image in RAW format. Basically, RAW format is as close to unprocessed as we can get coming straight out the camera. Let's take a look at one of these in Pixinsight from the lights that we calibrated on the Flame Nebula. There's one of these. See, it's grey. It means it's in grayscale. It's got no colour at all on it. If we put a stretch on that, you can see basically it's very, very blocky. There's absolutely no colour applied to this image whatsoever at this point. So what debayering does is it reconstructs the colour images from the grayscale raw images that our camera took. So here's how we do it. We shut down this image here, we don't need to show that anymore. Debayering is a process, so under processes, go all processes and then debayer. This pops up this box here, this process box. Basically what you have to do is make sure you're using the correct or bayer or mosaic pattern, which in the case of my camera is RGGB. The method, we stick to VNG, everything else at default. Add our files, which will be all of the files from our cal folder in our lights folder. So all of these. That adds all those files to the process. And our output directory, obviously we need to put these somewhere when they've been debayered. So we open that and we create a folder in our cal folder called, well I call it DB for debayered. Select that folder and click Apply Global. This will then go off and now debayer all our images and add the colour back in. So the process is finished. In the case of the 20 images that I processed, it took 1 minute 23 seconds. So we now close down the debayer box. We're finished with that. Let's just take a quick look at one of the images we just created. You can see the DB folder here. You can see now we've, as well as having the C after the file name, we've also added a D. That tells us that this particular file, or these files, have been calibrated and debayered. See how these letters after the file name are starting to make some sense? So we'll double click one of those and see what it looks like. We just put a quick stretch on that just to have a look. You can see, there you go, we've got a bit of colour back in. It's all red, but that will be dealt with later. You can see they're no longer grayscale. You can see here they're now RGB, red, green, blue. So great. So the next process we move on to will be the Subframe Selector. The Subframe Selector process is used for evaluating subframes, choosing them and setting weighting on the separate subframes. You need this to actually produce a reference image, which we're going to use later on in the processing. And you open it, obviously under Processes, all processes, just their Subframe Selector. This actually pops up 3 boxes: the actual Subframe Selector, the Subframe Selector Measurements window, and the Subframe Selector Expressions window. First we're going to take a look at the Subframe Selector where we add all our files in. So at the top here you'll see Routine, and we'll keep this on Measure Subframes. Quite simply add our files. The ones we want to add are the ones from the debayering process. So open your debayering process, select all of them with Control A, click Open. Adds all those files into the window there. Under System Parameters, let's just drop that up there to give us some room. Under System Parameters, there's 2 settings here you need to worry about: the subframe scale and the camera gain. You'll get this by looking up the details for your particular camera. On my Canon 450D it's 1.18 for the subframe scale and 0.2970 for the camera gain. So enter those numbers in those boxes there. Drop that back up there. Output files. As before, we need an output directory to put the accepted files in. You'll see in a moment that we may well be throwing out some images, some of the subframes, and we only want to keep the ones that we want to keep, and they will be going into a folder called, well I call it, Accept. like that. And the last thing we need to look at is this keyword, SS weight. This will be more important a bit later on. You can put that whatever you want, but I just leave it as SS weight. And the postfix _A. Click apply global, and this will now measure our subframes. Okay, so that process is finished. We now have this table of measurements populated with all sorts of numbers. The only one I really look at here is the FWHM column. So if I put sort by that, you can see which actual subframe had the best FWHM, which is that one there, which was subframe 19. FWHM means full width half maximum, which is a reference to star sizes. And you can see here, looking at the numbers on the FWHM, that they're all pretty good, which basically means, or could mean, that most of our subframes are pretty good. However, if you look at the chart here and you see a few spikes up here where the FWHM is too high, what you can do is if you click on, say, that particular one there, you can see it highlights that particular subframe. When you do the processing of the images using the subframe selector, it will exclude that one from the accepted folder. So you can use this if you've got a few spikes up higher, perhaps somebody turned a light on or something like that, then you can use this to exclude subframes from your accepted folder that you will be using for further processing. So for now, I'll uncheck that because I don't want to exclude any subframes from our processing on this process. We need to have a weighting for each image, and the higher the weight, the better the image. But at the moment you can see it's all zeros. So to get a weighting, what we have to do is apply a formula in Subframe Selector expressions. Now the formula I'm going to put in here is this formula here. I don't know exactly what all that means. What I do know is I got it from the Light Vortex Astronomy website and was developed by a guy called David Alt. So I'm giving them the credit here for the use of this formula, and we'll also put the full formula down in the comments section under this video. So what we do now is click this right arrow here, and you'll see it now applies a weight to each of our images. As I previously said, the higher the weight, the better the image. So if we now sort by weight in the measurements table, you can see here, according to the subframe selector, our best image is image number 20. So we need to remember 0020 is our best image because this one is going to become our reference image. So what we do now, return to our subframe selector, change the routine to output subframes and click apply global. And we can now close down the subframe selector because we're done with that. So let's take a look at what we've got. Double click the screen here. You can see here we're in our debayered folder, but remember we created the accept folder. So double click that and you can now see we've got this full of frames. And the CDA stands for calibrated, debayered and accepted. So you can see that these little letters that are getting put after each file name are now starting to mean something to show us where we are in our processing process. So the last step we need to make on the images that are in our accept folder, remember we figured out that image number 20 was our best image. We just need to rename that, and I'm going to put REF underscore in front of it, which tells me that that's our reference image because it was our best image. So that's it for this video. In the next one we're going to look at how we star align each of our images, also called registration.